Hello, I'm Fernando Varela Leon, and this is my Lab 5 Physics 2211, and I did the world's longest rope swing. So the purpose is to test if the energy principle is conserved and explain why a rope is like a spring. Preview the results, the energy principle was conserved, and treating the rope as a spring works in code. So these are some useful formulas: Newton's second law, F equals ma, F net equals F1 plus F2. And then we have the force of gravity, force of spring, the energy principle. The change of energy of the system is equal to the change of the work of the surroundings. The change in potential energies for gravity and spring are also both there. And this is what the experiment looked like. There's a YouTube video about the world's largest rope swing. And these are the initial conditions. So the rope is the rope, man, and the earth. The surroundings is nothing. The mass we're estimating to be about 70 kilograms, which is the average mass of a person. The initial position is negative 45.72 meters in the x component, and then zeros in them both. And we got that from finding the length of the rope from the video, as they stated. The initial velocity was 0 meters per second, and the spring constant we are estimating to be about 11,000 newtons per meter. And we just found it online for average climbing ropes, and L naught is going to be 45.72 meters as stated. So this is our code. This is just the visuals. This is the actual numbers where we plugged in. So here we have on the left the mass, position vector, velocity vector, and then change in time. Middle we have the constant L naught, and then the actual formula. And then on the right we have once again the energy and just the change of energy in the system. And here we can go even further, calculate gravitational force, calculate spring force, net force, and then applying the momentum principle. And on the right we have calculating the energy changes and specify energy changes for the plot. So this is what our model looks like. This is the rope at the bottom of the bottom. And so for our discussion, the energy principle does stand true. There is never a change in the total energy in the system. In real life, however, there would be a drag, so there would be a negative change in energy. So the delta E, the orange line, would probably be towards the negative side of things. And discussion, rope as a spring. A rope can be modeled as a parallel chain of atoms and spring-like bonds. As we can see, this is modeled on the right, and this can be thought of as one large spring with a large spring constant K. Possible sources of error. The code did not account for drag, so this will vary from real-world observations. The code could not model a drop before the rope was stretched, as was seen in the video. And the mass of the person and the constant of the spring or the rope were just estimates, so those are also subject to error. So in conclusion, the energy principle stands true as the total energy of the system did not change, and we can use a spring to model a rope swing to predict motion in extreme scenarios like this one, which was the world's largest rope swing. Thank you.